Hi everyone, this is Inder, and in this week's update on privacy preserving machine learning, we'll talk about data anonymization and whether if it's enough for protecting privacy of the data or not. Now we talked to a lot of companies and we also saw some companies online and we found that anonymization is the most popular technique used to protect privacy. And it's a bit intuitive also because you might feel that if you remove all the personally identifiable information from your dataset, then you won't be able to identify any individuals from the dataset. But that is not always true. In fact, most experts in privacy preserving would say that anonymization alone is never enough to protect your data's privacy. So in this presentation, we will explore this question in more detail, look at some examples of how anonymization is not enough, and also see a theoretical framework which proves that. So very first example comes from medical imaging. And medical imaging is one that is protected by many different regulations. So there are softwares to anonymize medical images. In this paper, the authors refer to one kind of medical imaging, that those are the MRI scans, and they use existing softwares to anonymize those images, anonymize the faces to be more precise of those images. So in this first technique, there is the actual MRI image of the face, and using a commercially available software, which is popular in medical imaging, the authors blur the face so that it cannot be identified. But they also train a GAN, and using that GAN, that's a general adversarial network, they were able to reconstruct those faces from the blurred images. Not just that, they went a step further actually. So they used another software which does not blur the faces but actually removes portions of faces from the MRI image. And then they trained their GAN on this data set too, and found out that these neural networks were actually able to reconstruct the faces even if the faces were actually completely removed from the original images. So these results are actually surprising to see that very potent anonymization techniques like removing the face of an individual would work, but it is not so. And on an interesting and a more technical note, they use cycle GANs. So those of you who are interested in generative networks, you'll find that many de-anonymization techniques are based on these generative models, and they're very pretty cool. So if you want to explore, this is one of the things which GANs can do. If you give it a video of a horse, it can actually turn it into a video of a zebra. So yeah, that was an interesting aside. Let's go on to our second example now. So our second example is from credit card data. And we used this study where the authors used 3 months of credit card transactions for staggering 1.1 million users. And I'm sure you must have seen these kind of data sets where they think it's been anonymized by removing the names of the users and replacing them with a user ID. So this data set has the shop where the transaction took place, the user ID, the time, the price, and the price bin. And to our surprise, these authors could actually de-identify these users in the datasets pretty easily. And they also proved that only 4 points were needed to identify over 90% of the individuals among these 1.1 million users. So what these 4 points means, they can be as simple as the example shown here. Suppose you want to identify Scott. Now you know 4 things about Scott: that he went to the coffee shop on 22nd of September. The next day he bought a pair of jeans, and the other day was a weekend, so he went to the pub and had a lot to drink. And the other day he was questioning his life decisions after heavy drinking and went to see his therapist. So these 4 points lands Scott in these 90% category, and he could be identified in this data set. And you see these green bars. So these green bars show that if you know 2 points, you can almost re-identify almost 40% of the data set. If you have three, almost 80%. If you have four, almost 90%. And these blue bars indicate that if you add pricing information, so the green bars actually were only using the information about shop and time, not the price. But if you have pricing information or just the price bin, the re-identification probability would even be higher. So these were two examples considering how anonymized data sets can be easily de-anonymized. But there are other studies also, which provide a general framework uh, of re-identification of data sets. Now, this is one of these studies here, and it tries to quantify how much susceptible a data set or a data instance in that data set is to re-identification. And they found out something very interesting. Number one is that if the number of attributes or number of you can say columns in your data set or number of things you are trying to cover about people, if that increases, the probability of re-identification increases. For example, in their data set, they found out if they use 15 attributes of the data set, they could almost re-identify everyone in the data set as shown here. So this is something to worry about actually, because in the modern times, we are dealing with big data. Your data has a lot of instances and a lot of attributes about those instances. So a person would have name, age, address, email ID, bank code, etc., etc. So these are different attributes. And they sort of quantify that how easy it is to re-identify the data sets. So that is the problem with anonymization. Now, but why should your company invest so much in enhancing your anonymization techniques? Because GDPR guarantees it. Actually, you can end up in trouble if you do not anonymize your data set properly. So how GDPR tackles it is actually very interesting. So it defines anonymization as something which, when done to the data set, it makes the people whose data is there in the data set unidentifiable. All the identifiable information has been removed from the data set. And thus, the data set is not in the scope of GDPR. You don't need to worry about it. But they also define another term called pseudonymization, which they mean that the anonymization techniques which actually work only as long as you do not consider additional data. So if you pair your data set with additional data and can de-anonymize the data set, then it's a pseudo-anonymization technique. And now the catch here is that all the pseudo-anonymization techniques are protected by GDPR. So many of you who think you have used an anonymization technique, but that if that anonymization technique is not potent enough, it falls into the pseudo-anonymization category and it is protected by GDPR. Something to worry about. So that's all. If you have any questions, you can feel free to write to me. My email ID is here, and if you want to engage more with us, also feel free to write. Feel free to write to me. Thank you. I'll see you guys next week. Bye bye.